The following podcast is a proud member of the Blue Collar Roots Network. Find all the shows by visiting bluecollarroots.com. He may seem like a mild-mannered engineer until you install an HVAC system improperly. Then the whole turning green Hulk shirt-ripping thing happens, and it's not pretty. Here's Bill Spohn.
Welcome back to another episode of the Building HVAC Science Podcast. It's our goal here, as you probably heard before, to help create better, more knowledgeable HVAC and building performance technicians by sharing information between these two worlds with the ultimate goal of making all of our customers happy in the homes they live in and the buildings they work in. Okay, this is Building HVAC Science. This is an interesting episode, I think. We're going to be talking about great indoor air quality with a gentleman by the name of Ty Newell, a company called BuildEquinox. HVAC and building performance contractors are seeing more homes built or retrofit to tighter levels. And that would mean blower door testing out like 3, 2, 1, ACH 50, or even less than that. So what do you do when a house can't breathe? Well, hopefully you see the humor in that statement. Of course, you build it tight and ventilate it right. And by the way, I looked it up. I think I found the original author of that phrase, and that would be Earle, Perera, and Lynn Parkins. You can find out more in the show notes about that. That goes back to 1992, by the way. So back to our podcast. Listen in today's Ty Newell, who's the founder of BuildEquinox, shares with us how he got to the point of feeling a need to create his own ventilation product, the Serve 2, the Conditioning Energy Recovery Ventilator. This is version number 2. So let's listen in as Ty tells us about the Serve 2 and BuildEquinox. How are you today, Ty?
Doing great. We're having a nice sunny day here in central Illinois.
That's a change as opposed to what's been happening across the Midwest lately, huh?
Yeah. The farmers are anxious to get in the fields, and they're not getting corn and beans planted as they'd like.
So, Ty, you're not a farmer, are you?
Well, I grew up in a rural area, so my brother and I had hogs and chickens and a horse, and we worked for farmers, so I did grow up in a rural area.
Very interesting. And now what's sort of been we'll be talking today about indoor air quality and a conditioning ERV, or Energy Recovery Ventilation System, called the Serve 2. But tell us a little bit about your background. What got you into this place where you've developed this product?
My background, I'm a retired mechanical engineering professor from the University of Illinois, but my whole career since the mid-70s has been geared toward sustainable living, resource conservation. My graduate work was all in solar thermal, and my academic research and teaching revolved around basically how we live on our daily allowance of solar energy. And so that's been a driving force. And as I retired, Ben and I had started a company which primarily is involved in consulting with many companies you've heard of, but mostly in the HVAC area, improving energy efficiency. And as we looked around toward what we felt were the needs for the next generation of homes, sustainably operated homes, we saw that air quality really was being left behind, that it's never been satisfactory in our homes for many decades. And the current generation of ventilation systems are also not what we need, and we're paying a price for it. So we looked at our background and expertise and then just started with a clean sheet of paper to figure out, with today's technology, sensors, and high-performance heat pump equipment, how we could design a better system, a smart ventilation system for basically making us healthier in our homes. And so that's where our focus has been over the past 10 years.
10 years. So you mentioned Ben. Ben is your son, Ben Newell?
Yeah, Ben, who's also a mechanical engineer, and then Alex Long, who is also a mechanical engineer, but the three of us are BuildEquinox. And so Ben is president of our company, and Alex is, while a mechanical engineer, say more on the control side of our system design and operation. And my background is then more on the thermal system side, the heat pump architecture side of things.
Got it. So the name of the product, it's called the Serve, C-E-R-V. Can you tell me what sort of the derivation, what does that name mean to you? What should it mean to people?
So on the one basis, it's a device that's meant to serve a home's occupants, that it's meant to be in the background and automatically give you peace of mind that your air quality is being taken care of. And then the letters stand for conditioning, Energy Recovery Ventilator. And so the idea is that with the heat pump, we can do better than just taking outdoor air and trying to approach indoor comfort conditions as we exchange energy. Instead, when it's warm and humid outside, we can deliver cool air to a home. And when it's cold outside, we can deliver heated air to a home. And so that's the origin of the description of the serve.
I'm a mechanical engineer too. So, hey, this is a party, right?
Yeah.
All of us together. You use some careful terminology, trying to approach indoor conditions. Does that mean that sort of the passive methods or those with, so those exchange cores can only do so much? Is that the concept behind that?
Right. With a heat exchanger core and then an enthalpy exchanger core, one that can transfer both mass as well as energy, that the best you could do would be to take, say, outdoor air and have it brought up to indoor air temperature, while indoor air ideally could be brought down to outdoor temperature. And any heat exchanger core can approach that if you slow the airflow down sufficiently or you build a large enough core. But when you do the energy exchange through a heat pump, then you have much more flexibility as well as capability to take, say, energy out of the indoor air as you exhaust it during the winter, and then put that energy back into the outside air, plus additional energy from the compressor and the heat pump so that you can deliver comfortable air to the inside.
And this heat pump we're talking about, what size is it physically and in capacity?
Yeah, so in capacity, it's nominally about a third of a ton. It changes capacity as any heat pump does as the outdoor conditions relative to indoor conditions change. But during wintertime, it will operate, the compressor operates at about 400 watts. And during summertime, our compressor is a best-of-class inverter drive compressor out of the appliance industry. But the conditions we operated at, it'll run at about 200 watts in the summer when it's doing cooling and dehumidification. And as an appliance-based compressor, then the reason we went with that is that appliance compressors are made to be used indoors. And so it's a very quiet compressor that similar to a refrigerator compressor. So it gives us good efficiency at a small tonnage as well as very quiet operation.
And the way this is connected is basically with ductwork from the inside to the outside. There's no element of the heat pump that sits outside. It's all within the conditioned space.
Right. It's all a sealed system, a hermetically sealed system, just like a refrigeration system. And then similar to other HRV or ERVs, we'd have two ducts going to the outside, fresh air supply, and then an exhaust, and then two branches that are supplying return to the house. We run at higher airflow rates than what most people are used to as far as fresh air ventilation. So we'll operate at around 200 CFM, where ASHRAE ventilation standards for residents is 62.2, would typically specify somewhere in the range of, say, 40 to 80 CFM for a typical size house with maybe 2, 3, or 4 bedrooms. The reason for a higher ventilation rate is twofold. First, the basic airflow that we need to stay healthy and to feel good, that we feel it should go back to where it used to be several decades ago, which is in the range of about 40 CFM per person, where typical rule of thumb has been about 20. And then the other reason is that as carbon dioxide's increasing in the out of doors, that's elevating the airflow rates we need relative to the level of CO2 in the outside to keep the indoors at a reasonable level of CO2 concentration. And for example, I was born in 1952. The CO2 in outdoor, the global average was around 300 parts per million of carbon dioxide. We've now exceeded 400, over 25% change in carbon dioxide. This means that you have to elevate the ventilation level in order to keep the same CO2 level that we had in a house in the 1950s. And that's going to continue. And so we need to have our homes, which we hope have been designed to have a durability for maybe 100 years, that they have the ductwork and the ventilation capacity over the next upcoming decades to keep the air fresh enough to keep us healthy.
Very interesting concept there. And I don't want to stick too much on the hardware because I do want to jump to the indoor air quality aspect and the health aspect because I know that's something you've delved deep into. But one more thing you mentioned is as the conditions change, the heat pump changes. How does the heat pump know that the conditions have changed?
Well, as in any heat pump, as you, let's say, spread the difference in temperature from the hot side to the cold side, the heat pump has to do more work in order to take low temperature refrigerant and then compress it up to a higher temperature level. And just like in a car engine, as far as compression, there's a mechanical limit to what we can do to compress gas from, say, one condition to another. And so as it gets colder outside, the refrigerant then takes more work to compress it up to, say, the pressure that goes with comfort temperature in a home. And finally, at, say, minus 20 to minus 30 degrees Fahrenheit, it gets to where the temperature is low enough where the amount that you can compress up to a comfortable temperature has been reduced. And at that point, a heat pump, as is typical in any heat pump, that you would have a coefficient of performance of 1, which basically means that the power that you put in the compressor is the heat that you're getting out, as opposed to a COP or coefficient of performance of 3, where you're getting, say, 2 units of heat from the outside coupled with a unit of energy from the compressor. So you're getting 3 units of total heat for every unit of electric energy put in the compressor.
How about in terms of the need for it to operate and what it does? It has sensors built into it, and how do they work?
Yes, so as a smart ventilator, we are monitoring carbon dioxide and then total VOCs, 2 separate sensors, and from our view, 2 essential sensors for managing air quality. And if either one of those gets above an occupant designated set point, so for example, my house, which you can see live data for the past 4 to 5 years online from our website, I keep the set point at 850 parts per million. And if we go above that threshold, the serve goes into fresh air mode and brings it down about 100 ppm below that threshold. And so basically it's looking at either one of those 2. Now, total VOCs or total volatile organic compounds, these are basically any molecules that are reactive. These could be things like formaldehyde. They could be body odor and volatile organic compounds that we put off because of our metabolism. They could be cleansers and cosmetics. They could be cooking odors. So there's just a whole soup of compounds that are reactive. Some are beneficial. The odor from chicken noodle soup, for example, has been shown to, in reality, to actually have beneficial effects when you're sick, beyond just feeling nice that someone's taking care of you.
Right.
And so VOCs, there's a whole range of things that can be putting VOCs into your house, while CO2 in all electric homes, which are the predominant type of home that we see our units going into, CO2 is primarily from our respiration. And we need to control both of those. CO2 does impact and impairs your quality of sleep and your productivity. And when coupled with high levels of VOC, you get a double dose of things that are impairing your ability to think as well as your health and productivity. And so by actively managing your air quality and doing it in an automated manner, just like a thermostat managing comfort, that you can go on and do the things that you're interested in and not be bothered with having to look at a meter and then maybe turning a ventilation dial up to 6 or 7 or down to 2 or 3. And there's a lot of energy savings as well by ventilating when you need it, as well as not ventilating when it's not needed.
Sure. During times of no occupancy, you won't have any CO2 generated, right?
And things like wind, even in a highly sealed home, like a passive house level home with very low infiltration, a wind speed change from 5 miles per hour up to 20 miles per hour is more than 4 times an increase in ventilation. It's a factor of 16, since infiltration goes with the square of the wind speed. And so when it's windy out or when it's very cold out relative to indoor temperature, when you have buoyancy-driven infiltration, it may be that most of your fresh air, even in a highly sealed home, is coming in largely because of the infiltration. And the serve then just adds in as needed relative to the occupant pollutant levels. And so there's door openings and somebody that has pets or kids that are constantly opening, closing the door. These are also adding levels of fresh air to your house. And so by having an automated way to bring in additional air when you need it, and then not doing so when you don't need it, it has substantial energy benefits.
Now, the product itself, since we're doing a podcast, we have listeners here. And of course, they could also go to your website, which is BuildEquinox.com. That's 2 words smushed together, EQUINOX.com. The product itself is built into a metal housing. Everything's sealed and filters. You can access the filters in it because you do have particulates or things that'll also come through the airstreams, correct?
Yes, and that's an important point. So the serve has built into it standard filters. So they're not a custom filter. They're a standard 10 by 20 size filter, and you can put in 1-inch or 2-inch size filters, as well as, depending on someone's sensitivity to pollens and other allergens, you can put in the MERV rating or Filtrete rating that you'd like, as well as in some areas where forest fires and smoke outdoors, putting in like a carbon impregnated filter. And so there's a wide range of choice of filters that can go into the serve with its standard openings. And as far as particulates, and in our newsletters that are posted on our site, about a year or so ago, we did an article on particulates. Currently, we have not implemented a particulate sensor in the serve. And the main reason, especially with our research background, we understand the difficulty and complexity of monitoring and measuring particulates over a long period of time in a manner that is at the sensitivity level that we need. These typically are $10,000 instruments in a laboratory to count particles and to do proper particulate sizing and characterization. Sensors that you do find in some of the low-cost indoor air quality sensors that you can buy, these give you some indication, but at the level that we would like to see, somewhere in the range of maybe 20 micrograms per cubic meter of particulate management. These sensors do not have accurate capability that we have found yet. They're good perhaps as event sensors, so that if you're stir frying something or in some other manner there's a blast or particulates going up to 1,000 or so, that they can catch that. But as far as actively managing or controlling based on these particulate sensors, we haven't seen that technology at the level that we would like to see to incorporate into our unit. But we are always watching and we are always assessing. However, as far as particulate management, we know we are doing a very, very good job of particulate management. And the essential feature in the serve that does that is our recirculation. And so this article that we wrote about a year ago on particulates, without recirculation, so where many homes just have a low constant flow of ventilation air, as is done with like ERVs or HRVs, or just once through supply or exhaust. You will have high levels of particulates, and you need to recirculate within a home in order to manage indoor generated particulates. And as of about the 1970s, as people were sealing homes better and better, we reached the point where most particulates inside of a home are now indoor generated rather than outdoor generated. And as of 2000, as we're seeing more and more builders able to build homes with, say, 6 ACH or 3 ACH air changes per hour at 50 Pascal on a blower door, well over 90% of the particulates within the home are indoor generated. Skin flaking off, cooking particulates, your feet rubbing and abrading and clothes abrading, but dirt that comes in from the outdoor on your feet. But the predominant particulates in a home are ones that we're generating or bringing in with us as opposed to blowing through infiltration cracks into the home. And these are not good particles to be living in, and it takes recirculation to filter them out properly.
I got it. Yeah. I want to take a moment and mention one of the sponsors of the Building HVAC Science podcast. It's BuildEquinox. BuildEquinox is the manufacturer of the Serve 2. That's the conditioning ERV. And of course, an ERV is an energy recovery ventilator. I like to call it a smart ventilator as it decides when to run based on integrated sensors. This very unique product contains a 1/3 horsepower variable speed heat pump to positively transfer more of the sensible and latent energy between this ERV's ventilation and exhaust streams. I'm so impressed with this product, I'll be using it in my own personalized performance home scheduled for occupancy by summer of 2020. So surf on over to www.buildequinox.com to learn more about the Serve 2, which, by the way, is American designed and made in a solar-powered factory in Urbana, Illinois. Also look for an episode of the Building HVAC Science podcast where I interview the inventor, Ty Newell. And when you get in touch, tell them the Building HVAC Science podcast sent you. Thanks. You have an interesting name for your company, and I know something behind that, but I want you to describe, what does BuildEquinox mean?
10 years ago, Ben, Alex, and I designed what we call Equinox House, which is my house. And part of my activity in renewable energy has been a lifelong dream to live on solar energy. And so we were at a stage as we started moving our company in this direction to demonstrate a house that is 0+ energy operation. And so we designed Equinox House, and the name Equinox comes from the distinctive overhang over clear-story windows on the house. And this overhang is designed so that when we hit the spring equinox, we no longer allow direct sunlight into those windows from the spring equinox to the fall equinox. So we only allow blue sky light in. Roughly 15% of the daily solar energy is in blue sky light on a clear day. But that's more than enough to give you good, comfortable light levels for reading in a home without any type of light inside the house. And then when we hit the fall equinox, within a matter of 2 weeks, again, because of this overhang design, we allow direct sunlight into the house. And from that point on, we're also getting the advantage of direct solar gain into the house. And anyone that looks up some of the articles we've written, Ben and I wrote a 12-month series of articles for ASHRAE on design of Equinox House. Several features from windows to insulation to thermal mass to ground coupling and air quality and appliances. You'll see a lot of the special features, but basically it's an engineered house that's economically optimized. And when you do things right, the house, it's $125 a square foot house, similar to all the neighboring homes. We just don't have a utility bill other than the customer service fee.
That's just the interconnection fee so that you can do that plus factor, right?
Right.
So that's a very ambitious goal, but you achieved it. That's excellent. Congratulations.
Well, I had to get quite old in order to do it, but after being in this area for nearly 50 years, and I've just been wired for whatever reason to see that it just feels to me like we got the foot on the accelerator and we're heading toward a brick wall. And I just like to see us try to come up with solutions so that it's not forced on us and in a manner that's just going to be for future generations a difficult hole for them to get out of without some preparation.
The fact that it's called Serve 2, that must mean there was a Serve 1. So are you in your second generation of products?
Yeah. So we're in the second generation. And so the initial prototypes for the Serve were developed around 2008. And actually, the first, say, reveal of that activity was a presentation that Ben and I made at the second North American Passive House Conference that was up in Duluth, Minnesota, the second or third, but we've been going to them since about the second Passive House Conference. And that was cardboard and duct tape and a couple heat exchangers and a heat pump that we rigged together just to see if we could get that to function as we thought it would. And just as far as background, our business, which was primarily conducting consulting for large corporations, Ben and Alex and I had designed the first air conditioning system to undergo mil-spec 810 standards for an air conditioning unit that is now deployed throughout the world, but is the first to qualify for managing the air conditioning needs of the F-35 when it's on the ground for maintenance. And what's quite spectacular about that system, and that we're very proud of developing that, is that it's a very modern, technologically advanced system. It's now over 10 years old, but it has to operate from minus 40 Fahrenheit to 140 Fahrenheit. So that's basically what the mil-spec 810 standard requires. In addition, it has to blow air that's at 6 to 7 psi, which doesn't sound like a lot of pressure, but in terms of blower power, a lot of the air conditioning is just getting the heat from the blower power out of the air, along with the extreme conditions it runs in. So we've got a background where from refrigerators to residential size heat pumps to very specialized high performance. This is a 25-ton air conditioning machine. And we've since built similar commercial aircraft conditioning machines that are as big as 120 tons. And these are deployed at airports around North America. So we have a background in doing that type of design. And so in putting together this type of system for energy recovery in a residential system, while this is a totally new machine and very advanced as far as microchannel heat exchangers, inverter drive compressor, digital expansion valves, that we've done this before. So we're very well versed in how to do that, how to get things fabricated, how to assemble.
So you're building obviously very solid equipment, having to build a mil spec. And also I noticed from studying your brochures, your website, you are UL and CUL listed so that you've applied for and received those kind of certifications.
Yeah. So we understand the process, and the UL process, it's a very good process because it is another set of eyes looking over our shoulders to see that things are safe as far as the pressures and the components used in the refrigeration system, that the electronics design and all the electronic design is our design. We're fortunate that we have the capability to design the microprocessor controls and incorporate the sensors and the communication systems, as opposed to relying on third-party vendors for those components. What that gives to us is good flexibility in getting the system that we want for managing things as we see are needed. But it also gives us control so that if, say, a larger corporation like a Honeywell controller or a Earle or JCI, that when they decide they're going to move on to a different model, as a small company, we'd be left hanging and then scrambling to then figure out how to convert our unit over to the next generation of their model. And so, yeah, with the Serve, it's when there's a problem, there's only one place to point the finger, and that's at us. And so we take care of any issues that are coming up or answer any questions as people are installing these. And right now we are basically early adopter. And so people regularly ask us, we've got a 5-year warranty. How do we know we'll be here for 5 years? Well, we've now had it on the market for 7 years. And so those very first serves that came out initially in 2013, those have made it. And as you mentioned, about a year ago, we brought out the second generation serve. So as we started seeing how people were using the configurations that would make it easier to install, things that would make it easier for us to fabricate, as well as what would give us a lead into where we see things going for the future, we designed those capabilities into now the second generation unit.
The unit itself, does it have provision for, or do you have it in your timeline or your product map to have other sensors in it or other upgrades, or are you satisfied with the state of the art right now?
Both. We see that we're ahead of the field by quite a bit, although you never know what's out there about to be released, so it's good to run scared. But we have built it as a platform that we can continue expanding. And so, for example, one of the areas that we're ready for is as we go into more complex homes, and we're in homes as big as, say, 10,000 square feet that have multiple units in it, multiple serve units in it. But where a lot of these larger homes or more complex homes, it still tends to be maybe just 2 people in it, and where they are and where they're generating pollutants, that 90% of the home may have good air and not need fresh air. And so more precision zoning and the capability to exhaust air from where it's most polluted and supply air where it's most needed. These are capabilities that the Serve 2 has inherent in it. So our distributed wireless sensors, our wired and wireless zone dampers, these allow us to expand into, say, more complex projects and to more effectively manage air quality in a home. The Serve has, and with the first generation as well, it has online connectivity.
I was going to ask about that, yeah.
And we introduced over-the-air upgrading so that as new algorithms, new analytics, new features are developed, we broadcast those capabilities out to existing serves. So serves are continually being updated after somebody purchased one, and diagnostics and other tools that just help us keep making the unit better and better.
There's another aspect to, again, sort of, I guess, your passion or what you said you're wired for, the factory that you build it in. Tell me a little bit about that, the facility.
Yeah, so we're in Urbana, Illinois, kind of the middle of nowhere. And at least myself, I enjoy being from nowhere. This is where serves are built. And although we have partners who are fabricating our sheet metal, who are fabricating other parts, shafts and dampers and other components, and then we're assembling as well as doing the heat pump brazing and assembly here. But our business facility, it's a 4,500 square foot Morton building, typical metal-sided building, but it is a net zero building as well. 10 years ago, we added our first amount of solar PV for the building. And then about 4 years ago, we added another 5 to 6 kilowatts of PV. And that was enough, along with additional insulation and ceiling and window improvement, to get the building to net zero over the course of the year. And so we're very pleased that, and me especially, that where I live as well as where I work are powered by the sun. And so serves are also solar manufactured.
Awesome. That's a claim few can make.
And we're hoping, though, we see more and more, and you see major corporations like Apple and Ford and other companies just seeing that it is economically viable and there's good benefits by moving in that direction. But we're very pleased that we're able to do that at this stage.
And I know that some listeners are very much into data. Can you tell me about the kind of data and where you get it from?
Yeah, so we're very data driven. And from our website, for example, you'll see a report called the Vermod Report. And Vermod is a manufactured home corporation in Vermont, White River Junction. They build homes that are the basic module is about 1,000 square foot. And we conducted a study about 4 years ago as Vermods were first coming out, as well as serve units. The Vermod is based on a low temperature mini split heat pump. In their case, they're using Mitsubishi Hyperheats. Heat pump water heater along with a serve for managing air quality. And we did a very detailed study of 13 of these homes, ostensibly identical homes, but for sure very non-identical people living in them. And that Vermont report, which people can download, it's one of the few reports I know of that has over a 2 to 3 year period, very detailed data on the energy uses from the various appliances to plug loads to heat pump, serve energy, but also air quality and then comfort within these homes. And that's the type of research that we conduct to allow us to see that the serve is operating very, very efficiently. So in the case of these Vermont homes, they exceed the requirements of both the North American FIAS Passive House Institute US standard, as well as the European Passive House Institute standard, as far as energy usage per year per square foot of house. And so while a smart ventilation system is a kind of a difficult thing to, say, put one performance number on, because it's a very dynamic situation, we know from very detailed measurements that homes with smart ventilation coupled with high performance heat pumps on both water heating as well as comfort conditioning, that you get a package that's very synergistic and that gives you very high overall house energy efficiency. So we do that along with then each serve is archiving indoor air quality as well as comfort conditions for people. And our intention is that we grow what we've been calling the serve community. And the serve community is meant to be archived data for your personal use so that you can see and hopefully start to link what things make you feel better and what things don't. So as you look at peaks and valleys of how your volatile organic compounds and carbon dioxide levels have been changing, or that maybe the type of filter that you've been using during a certain period of the year, that this archive data can let you go in and see whether or not you want to keep the CO2 VOC level at maybe 850 parts per million, or maybe 1,000 seems okay. But the goal is that that data, and as we learn more and more from that data, that's going to help us feel better. Where we intend to go with it, and we're already studying this, but these days of artificial intelligence, which is just pervasive now, but the power of big data and artificial intelligence when used properly, and by properly, I mean for our benefit, is
for the benefit, sure.
just blasting us with pop-up advertisements. So we see this as a way to take, say, maybe whether you've exercised today, the foods you've eaten, whether the sun was shining, weather front's been coming through, how much time you might have been working or doing this, that, but disparate pieces of data that for a human are very difficult for us to maybe link together for why I feel better or why I don't. But if we can, for example, help somebody mitigate or avoid maybe an asthma attack or a bout of hay fever or a migraine headache or maybe a bout of depression or other things, that we start seeing the connection, and artificial intelligence is really just a tool for helping us to correlate things that are very difficult for the human to see through. And so we feel that this data that's being archived will help each of us personally, but then in general help the public as we accumulate enough data to just see what makes us feel better and what things we want to try to avoid or mitigate that make us feel not so good. And so that's our mission, is really our well-being and health and how to improve those things.
Absolutely awesome. And I'm one of the majority owners of True Tech Tools, and part of our mission is to help technicians deliver comfortable, healthy, and energy efficient living spaces. And that's what we really feel we're about too. So there's a huge amount of synergy between what you're talking about and the way we approach our work too. So glad to have you on board with this. Find someone else who's on board with this concept. Great. This is fantastic.
Yeah, and these folks are on the front lines. And so right now, as I'm sure you see, that when you look for what homeowners are most interested in, a healthy home is right at the top of the list. But people are trying to understand, what does a healthy home mean? And so hopefully we're starting in our efforts putting a quantitative basis into those pieces that help you understand if your home is healthy or not.
Fantastic. I'd like to wrap up our discussion here in the podcast. We covered a tremendous amount of ground, and I have a feeling I'm going to bring you back because, in full disclosure, you're working with me on my new house project to help provide me a Serve 2 for my house. And so I'll be one of those data aggregators and adding information and having a lot of good dialogue with you as my new house comes together. So this is a really great thing and I haven't met you in person yet, so I got to do that. That's got to be taken care of soon.
Yeah. Well, as we talked about, sounds like we both head toward Northeast Ohio in the Canton area now and then. So hopefully we will get to cross paths there. And then we always enjoy stopping by project homes and seeing them. So for sure, one of us will be passing by and hopefully get a chance to see your house.
Yes, absolutely. You're welcome. So any closing thoughts, Ty, today?
We're just excited about the future. We feel that we're on the front of this wave and it's building up. We're feeling that people are understanding what we're doing, but we are basically a word of mouth company. And so we're just growing in a more, say, natural or bootstrapping type of manner, but we like how things are developing, and we're excited about the projects that we've been involved in and the enthusiasm of the folks that are contacting us and working with us.
I'll say one more thing. We'll put links in the show notes to a lot of things we talked about here. Basically, their website is a treasure trove of information. I think the one thing that really blew my mind was the April 24th webinar that you did, where you gave a very comprehensive overview of really IAQ data and talked about better sleeping, better health, better productivity, better cognitive function, and backed all these things up, all this data up. So I really encourage listeners to go out and seek out. If you're interested in more information, it's there on the BuildEquinox.com website.
Yeah, thank you very much, Bill. I sure appreciate that.
Very good. So we'll wrap up here today, and we'll be talking again later. And listeners of the podcast, please take a look at the show notes and take a look at the links to find out more about Serve 2 and BuildEquinox and Ty and Ben Newell. Thank you very much. Have a good day.
Thank you, Bill.
Well, thank you for listening to this podcast about the Serve 2, which is a product from BuildEquinox, which is Ty Newell's company. I really can't wait to be using this new product. It's going to be integrated into my new high-performance home that we're building for occupancy by the summer of 2020. So I'm sure I'll be talking more about this product in the context of actually having it installed in my own house and monitoring with my own indoor air quality monitors. You can find other trade-oriented podcasts, Tool Pros, Service Business Mastery, HVAC School, that are part of the Blue Collar Roots network at bluecollarroots.com. We're trying to do our part to help transform and professionalize the trades by filling the skills gap through training and communication. And I'm stumbling over words, so I'm working on my communication skills too. There's some other great related resources and influencers out there, including Zach Ciota of HVAC Shop Talk, the HVAC Reefer Guy, Mike Mayberry, Grace and Corbett Lunsford of HomeDiagnosis.tv, which is the first TV show for home performance, building performance. Of course, Jim Bergman, who's doing a great job with the Measure Quick YouTubes and other Facebook posts on this whole concept called Measure Quick, which I think is really dynamic and going to be changing our industry. Here's a quote or thought for today related to our topic. To keep the body in good health is a duty. Otherwise, we shall not be able to keep our minds strong and clear. And that's by Buddha. Some of the topics we talk about require technical training for proper interpretation or safe execution. So if you're a trained pro, you can go right ahead. And if you're not, please consult and hire a trained pro. The Building HVAC Science podcast is a production of TrueTech Tools. The opinions voiced here are those of my guests or myself, depending on who is speaking, of course. And if you're in the market for some of the tools or test instruments that we mentioned in our podcast, take a look at what TrueTech Tools, TruTechTools.com carries. You can use the code HVACBS for a nice discount. I want to thank you again for listening and following us on the Building HVAC Science Facebook page, hopefully. And if you've not subscribed, please do so. Please subscribe to the podcast. Clicking subscribe will ensure you're up to date on everything that's happening in the world of building HVAC science. Thanks again. Have a wonderful, healthy day.